Let's do another example. Let's look at the function f of x equals x to the third minus 6x squared. We're going to look at 5 sub-questions, actually, 5 parts. So we'll solve f of x is greater than 0, solve f of x is less than 0, solve f of x is greater than or equal to 0, solve f of x is less than or equal to 0, and graph the function. So all of these 5 tasks are, I guess, can be a little tedious, but the work that's necessary, like the tedious amount of work that's necessary for any one of these questions, you basically get to reuse the work for all of the questions, which is why all 5 parts are here. So let's just go ahead and just to pick apart, the first one, f of x greater than 0, or if you substitute the f of x with an x cubed minus 6x squared, we want to look at x cubed minus 6x squared is greater than 0. Now, same issue as before, it's a polynomial inequality, and so this becomes really just too much to work with as written, so we're going to first look at the equation. Okay, instead of this polynomial inequality, we first convert the inequality to an equation. Now, these are not the same problem. Okay, so I know that so far we've been sticking consistently to the idea that an inequality would always turn into an inequality and an equation would turn into an equation. But for now, we're going to examine the equation because we want to see where to break things up for our sign chart, and we come back to the inequality later. So we look at the equation because we can hope for the zero product property to apply. We couldn't apply the zero product property to an inequality, but we can to an equation as long as there's a 0 on one side and a product on the other. Now there's a 0 on one side of this equation, but we don't have a product. We've got a difference with a minus, so let's factor. Take this x cubed minus 6x squared equals 0, factor out an x squared on the left side, so you have x squared times the quantity x minus 6. Now we can apply the zero product property to this equation. Again, not to an inequality, but to an equation. So the first factor, x squared equals 0, or the second factor, x minus 6 equals 0. Square root both sides of the first equation. There's technically a plus or minus, but x equals plus or minus 0. We just simplify to x equals 0. X minus 6 equals 0 simplifies to x equals 6. These 2 dots drawn show the only places where f of x is equal to 0. Okay, that's the equation. And because we've solved the equation, which has these 2 solutions, x equals 0, x equals 6, now we can go back to the inequality, right? So we solved the equation only because we needed to apply the zero product property. So we know what happens right when x equals 0. We know what happens right when x equals 6. At those 2 locations, the y value is 0. But what happens in between 0 and 6? What happens when x is between 0 and 6? Like when x is equal to 5 or 5.5, or when x is equal to 3.2. What happens also to the left of x equals 0? What happens when x is negative, in other words? What happens when x is negative 10 or negative 11 or negative 12? What also happens when x exceeds 6? So what happens when x is 6.1, or maybe when x is 7 might be easier to deal with, or when x is 8? That's what we need to figure out. Figuring out what happens. Okay, we know what happens when x is 0. We know what happens when x is 6, but finding out what happens in between, and then on the extremes, there's 3 separate pieces, in other words. So there's the left piece, the middle piece, and the right piece. Figuring out what happens in those 3 pieces will help us answer not only this first inequality question, but all of the inequality questions, as well as the graphing question. So we'll put this chart at the top that just of locations where f of x equals 0, where the y value is 0. The y value is 0 when the x value is 0. The y value is also 0 when the x value is 6. So you're noticing with my language here, you got to be careful what's x and what's y. There's a lot of moving parts here. So y is 0 when x is 0, and then y is again 0 when x is 6. You can go back and check. If you go up to the function, it's written here in its distributed format and in its factored format. If you plug in x is 0, if you input x is 0, you're going to get an output of 0. When you input x is 6, you again get an output of 0. So what happens in between? That is what happens in this part when x is to the left of 0, so in the interval where x is in negative infinity to 0. What happens for x between 0 and 6? In other words, when x is in the interval 0 to 6. What happens also for x bigger than 6? What happens to f of x when x is in the interval 6 to infinity? So that's what we're going to analyze. These 3 intervals, negative infinity to 0, the interval 0 to 6, And then the interval 6 to infinity here, there are no union signs. In fact, I just drew these vertical lines to try to prevent people from drawing in union symbols. We're not ready to answer any question about inequalities yet. We still have some work to do by building this sign chart. So there's two factors. There's an x squared factor and there's an x minus 6 factor. So let's see what happens to the x squared factor. So first, what about right here? We need to pick an x value in this interval negative infinity to 0. Maybe we pick x to be, I don't know, negative 3. So then negative 3 quantity squared would be positive 9. So that, yeah, this x squared is positive, so we put a plus sign here. Then how about for x values between 0 and 6? Now it doesn't matter what number that you pick for x between 0 and 6, the same result's going to occur. Let's say we pick x equals 3. That's a number. 3 is a number between 0 and 6 for x. Okay. Then x squared is 9, which is positive, so there's a plus sign here. Finally, for this last column, pick an x value bigger than 6. For example, let's just pick x as 9. Then 9 squared is 81, which is positive. So this row is actually all pluses because, well, when you square things, you get a positive. There's this other factor, though, of x minus 6. So what happens to the x minus 6 factor? Again, we're going to go through each of the intervals individually. So in this first interval, let's say you pick x equals negative 10. That's inside negative infinity to 0. Then x minus 6 would be negative 10 minus 6. In other words, negative 16, which is negative, so that's why there's a minus sign here. Then let's take a look at picking an x value between 0 and 6. For example, you could pick x equals 3. You could pick x equals 4. Same result if you did. We're just trying to find out if we should put a plus sign or a minus sign here. Now, there's a minus sign here. I get that 3 is not negative. I get that 3 is positive, but that's not our concern. We picked 3 because 3 is between 0 and 6. And then you take that 3 and you plug 3 in for x right here. Then you have 3 minus 6, which is a negative number, negative 3 specifically, and that's why there's a minus sign written here. Finally, for the last column, 6 to infinity, pick an x value between 6 and infinity, like you could pick x equals 9, and then 9 minus 6 would be the number positive 3. Since we got a positive, there's a plus sign here. And you don't have to pick x equals 9. You could pick x equals 20, because then 20 minus 6 would be 14, still positive. Okay, there's still that plus sign there. Now, f of x is the product, right? F of x is x squared times x minus 6. Product meaning times, right? So it's this times this. So a positive times a negative is a negative. What about for x values between 0 and 6? You'd always have a positive thing times a negative thing, which will give you negative. What about for x values bigger than 6? You'll always have x squared. The x squared part will be positive. The x minus 6 part will be positive. So positive times a positive is a positive. So we're just trying to work one factor at a time. I know it's a lot of work to show, but it's just easiest to think about what's going on one factor at a time. It's just too much to think about otherwise. And then in the bottom row, we're just, multiplying a plus sign and a minus sign, really. We're just saying any positive number times any negative number is a negative number. Any positive times any positive is a positive. And so this bottom row really gives us kind of all the information we need in order to answer all of the inequality questions. So here we go. We've summarized up here a picture. The blue dots are where the y coordinate is 0. And then the bottom row of this chart, just taken from the last slide, shows when the y coordinate is negative, when the y coordinate is negative, when the y coordinate is positive. Okay, so we know when y is 0 here and there, and then we know when y is negative. That's this for x happening to be this, and y is again negative when x is between 0 and 6, and y happens to be positive when x is bigger than 6. So looking at this plus sign here, that's how we answer, okay, f of x is bigger than 0, that's where the plus sign is, for x in 6 to infinity. Now, f of x is greater than or equal to 0, we've got to include this 6 here. Now, what about f of x less than 0? So that you'll see a minus sign here and there, and so we need to include both of these intervals and we union them together. Now some people might say, don't we just include 0, but actually when x is 0, y is 0, but we're talking about y less than 0. Finally, for f of x less than or equal to 0, we just really change all the parentheses to brackets except the one place you can't, right, by the infinity symbol, because now we need to include 0 and 6. Here happens to be a picture. Okay, again, this is a fairly rough picture, but you'll see that the two x-intercepts are at 0 and 6. and you see the fact that the y coordinates are negative, pictures below the y-axis here. Then when x is between 0 and 6, so from here to there, again a minus sign. So this doesn't pierce through, but rather bounces right here, and you see that the graph is again below the x-axis because the y values are negative. Then when you get to x exceeding 6, then the y values are positive, so that's why after 6 you see here the y values are positive. I think I cannot stress enough that when thinking through these, you need to not just say it's positive and it's negative. You've got to talk about x positive or y positive or things like that. For instance, take a look at this minus sign, right? You don't want to say it's negative. Here, you'll note that I don't like, in fact, using the word it. I did that a little bit out of mockery or whatever, but like when x is between 0 and 6, now that when x is between 0 and 6, we're talking about numbers like 1 and 2 and 3 and 3.8 and whatever. Those are all positive x values. So when x is between 0 and 6, y is negative. See how confusing it would be if we said something like when it's positive, it's negative? That would make no sense. When it's positive, it's negative. So that's not useful language to describe what's going on. There's x values, there's y values. So we better be clear that when x is between 0 and 6, and yeah, for those values x happens to be positive, then y is negative. And so that describes this part of the graph when x is between 0 and 6, that's down here. In fact, it's even would be incorrect to say when x is positive, y is negative, because when x is positive, y can be negative, or this part right here, x is still positive. Like when x is 7, y is up here. So we don't even really want to say when x is positive, y is negative. It's when x is between 0 and 6, y is negative, and then when x is a positive number between 6 and infinity, y is positive. So over here, there's some x values that are positive, and over here, there's x values that are positive. So the language needs to be extremely careful here. So you certainly don't want to say things like when it's positive, it's negative, but even trying to say when x is positive, y is negative is not quite correct. It's misleading, because when x is positive, but only up to x is 6, then y is negative, right? So when x is a positive number bigger than 6, y is positive. So be very careful. Don't talk with the word it. Talk in terms of x's and y's, okay?